Hi everyone. Today's mini lesson comes to you from Lesson 2.7, Properties of Exponents. First example, we're going to multiply exponents that have the same base, and we can write the product as 1 power. Now when we multiply, we're actually adding the exponents together. So in the first example, I'm going to have 4 to the 6th, but then I can actually add the 5 and add the 0. And I'm sure your teacher told you this today, but anything to the 0 power is actually equal to 1. So 4 to the 6th plus 5 plus 0 would be 4 to the 11th power. And it says write the product as 1 power, which means stop right there and keep it as 4 to the 11th. If we were to multiply 4 11 times, that would be a huge number. You're doing something wrong if you're doing that on the test. We would never ask you to do something that lengthy. Let's look at the next one. 17 to the 5th, and then just 17. Anything that's by itself actually has an exponent, which is 1, because there's technically 17 there. So 17 to the 5th times 17 technically to the 1st, so 17 to the 5 plus 1, which would be 17 to the 6th. And your answer's finished because you were told to write the product as 1 power. G squared, g to the 4th, g to the 3rd, same thing. We're going to add up the exponents. That just tells us how many g's are being multiplied together. There's 2, there's 4, there's 3. We add them together. And we have g to the 9th. Then the last one here, 4 squared times 5 cubed. Since the bases are not the same, 4 and 5 are not the same number, we can't combine these. Could we simplify them? Yes, but that's not what the question's asking. It says write the product as 1 power, which we cannot do. So I'm just going to circle it. That's as far as you can go for that one. Now when we divide, so opposite of multiplication, when we divide, we want to subtract the exponents. So 10 to the 5th, 10 cubed, 5 minus 3, and you're going to take the numerator minus the denominator exponent, would be 10 squared. And it says write the quotient as 1 power, so just 10 squared. I want to show you an alternate way of doing this problem. And 10 to the 5th over 10 cubed, there are 5 tens in the numerator. I'm going to do this pretty quickly here for you. I like this method as well. And there are 3 tens in the denominator. And what do we know that something is when it's over itself is a fraction, like 7 over 7 or 4 over 4? It just turns into 1. So any 10 over 10s, if they're being multiplied, can be simplified out, and we're left with 2 tens in the numerator, which is 10 squared. So that's just a tricky way of doing it. Let's try the next one. 5 to the 4th over 5. Remember I said anything by itself is an exponent of 1, so 4 minus 1 would be 5. And then r to the 20th divided by r to the 15th, r 20 minus 15 would be r to the 5th. And then 6 to the 4th divided by 6 squared, so it'd be 4 minus 2, which would be 6 squared. And we were told to leave the quotient as 1 power. Some of those are pretty easy to do, but we are still going to leave them as 1 power. Then in the word problem here it says there are 2 to the 5th iPads in each Apple shipment box coming to Fort Couch for the new school year. There are 2 to the 9th boxes en route to Fort Couch. How many total iPads are being shipped? Write the answer as 1 power. So in the boxes there are 2 to the 9th boxes, and in each box, so there are 2 to the 9th boxes, and in each box there are 2 to the 5th iPads. So you're right, we're going to multiply them together. And when we multiply exponents that have the same base, you're going to add, so 2 to the 9 plus 5, so 2 to the 14th iPads. Now that would be a really big number if we'd multiply that out. Writing with exponents is a way we can write really big numbers in a small fashion. All right, thank you, bye.